Introduction. All matter is composed of basic elements that cannot be broken down to substances with different chemical or physical properties. Elements are substances consisting of one type of atom. For example, carbon atoms make up diamond and also graphite. Pure 24-karat gold is composed of only one type of atom, gold atoms. Molecules are compounds in which the elements are in definite fixed ratios. For example, water, glucose, ATP. Objectives. At the end of this lesson, you'll be able to know about laws of chemical combination like law of conservation of mass and law of constant proportion. Discuss Dalton's atomic theory and understand about atoms, molecules and mole. Laws of chemical combination. Chemistry deals with the matter and the changes occurring in it. Chemists are particularly interested in these changes where one or more substances are changed into quite different substances. They had found that these chemical changes are governed by some empirical laws known as laws of chemical combinations. These laws are law of conservation of mass, law of constant composition, or law of definite proportion. Law of conservation of mass. According to this law, matter cannot be created nor destroyed in chemical and common physical changes. For example, zinc react with sulfur molecules to form molecules of zinc sulfide. Law of constant proportions. The law of constant proportions, which is also known as the law of definite proportions. This law was stated by Proust. As in a chemical substance, the elements are always present in definite proportions by mass. In formation of water compound, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Dalton's atomic theory. Dalton's atomic theory provided an explanation for the law of conservation of mass and the law of definite proportions. The postulates of this theory are: 1. All matter is made of very tiny particles called atoms. 2. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. 3. Atoms of a given element are identical in mass and chemical properties. 4. Atoms of different elements have different masses and chemical properties. 5. Atoms combine in the ratio of small whole numbers to form compounds. 6. The relative number and kinds of atoms are constant in a given compound. Atoms. Our entire world is made up of atoms. We may not be able to see them, but they are there and constantly affecting whatever we do. Atoms are very small. They're smaller than anything that we can imagine or compare with. More than millions of atoms, when stacked, would make a layer barely as thick as this sheet of paper. Through modern techniques, we can now produce magnified images of surfaces of elements showing atoms. Example: silicon surface showing atoms. Symbols of atoms of different elements. Dalton was the first scientist to use the symbols for elements in a very specific sense. When he used a symbol for an element, he also meant a definite quantity of that element, that is, one atom of that element. Berzelius suggested that the symbols of elements be made from one or two letters of the name of that element. Symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. Each element has a name and a unique chemical symbol. For example, argon, Ar, chlorine, Cl, zinc, Zn, etc. Molecule. A molecule can be defined as the smallest particle of an element or a compound that is capable of an independent existence and shows all the properties of that substance. Molecules of many elements such as argon, Ar, helium, etc. are made up of only one atom of that element. 2. A molecule of oxygen consists of two atoms of oxygen, and hence it is known as a diatomic molecule, O2. If three atoms of oxygen unite into a molecule instead of the usual two, we get ozone. Atomicity of elements. The number of atoms constituting a molecule is known as its atomicity. Let us look at the atomicity of some elements. Molecules of compounds. Atoms of different elements join together in definite proportions to form molecules of compounds. For example, water, ammonia, carbon dioxide, hydrogen peroxide, etc. Did you know the concepts of both matter and mass conservation is widely used in many fields such as chemistry, mechanics, and fluid dynamics? Historically, the principle of mass conservation, discovered by Antoine Lavoisier in the late 18th century, was of crucial importance in changing alchemy into the modern natural science of chemistry. Steel is harder than iron because its atoms are bound together in a more rigid crystalline lattice. Wood burns or undergoes rapid oxidation because it can react spontaneously with oxygen in a chemical reaction above a certain temperature. Sugar and salt dissolve in water because their molecular ionic properties are such that dissolution is preferred under the ambient conditions. Summary. Let us summarize what we have learned. During a chemical reaction, the sum of the masses of the reactants and products remains unchanged. This is known as the law of conservation of mass. In a pure chemical compound, elements are always present in a definite proportion by mass. This is known as the law of definite proportions. An atom is the smallest particle of the element that can exist independently and retain all its chemical properties. A molecule is the smallest particle of an element or a compound capable of independent existence under ordinary conditions.